Hello and welcome to the second presentation during the second day of our Blockchain Community Z Days conference at EPAM. If you've just joined us or you're watching this recording, my name is Jan Mazurek and I will have the privilege to be your host and moderator during this presentation, Introduction to Zero-Knowledge Proofs, Advantages and Disadvantages of Cryptographic Methods. Our speaker today is our own Dmitro Ivanenko, who is working as a security system engineer. Dmitry also has a PhD, he's also a PhD graduate in cryptography and has the experience in working in the police force in the cybersecurity department. I encourage you to take advantage of our community portal throughout the presentation and comment the topic and ask questions in the Q&A section to the speaker. The most upvoted questions will be later on asked at the end of the presentation to our speaker. With that said, Dima, please share your presentation with us, please share your knowledge with us, and I wish you a good presentation.
Thanks, Jan. Hello, everyone. Yes, Jan said it's true. I am ex-cyber policeman, and my previous job, I took part in investigation criminal case when I looked for fraud, when this fraud used cryptocurrency, because these people want to hide transaction, and in this moment it was interested because it's interesting method and approach this hide information in blockchain and other system. It was interesting for me because on education I am crypto analytic, and it would be interesting how worked it. Today, many different methods exist which are hidden or protect participant data, and it's a proof of knowledge. When knowledge is hidden, it's use parent-based cryptography and multi-pair computation, and to use it ring signature, and use group signature, and use multi-signature, and this and today we talk about zero form knowledge of proof. And first, it's my picture. And first, why? We need to understand how work this thing, and you understand why needed zero knowledge of proof. People demand that personal information like medical and financial data be hidden from the public. And maybe good answer for this question, it's if your personal data is never called, you cannot be stolen this information. And what is zero knowledge of proof? Zero knowledge of proof, it's a protocol which allow you provide that you know same secret and maybe many secrets to somebody at the other end of a communication without actually revealing it. For example, zero knowledge of protocol, it's a way of doing authentication where no passwords are exchanged, which means they cannot be stolen. It's cool because it's make your communication so secure and protected that nobody else can find out what you communicate about, or maybe files you are sharing with each other. And this protocol have same properties. And first properties, it's completeness, and its situation. If state is true, verifier will be convinced by prover. And second property is soundness. It's state it's false. Cheating prover cannot convince a verifier it is true. And third properties, it's zero knowledge. Verifier learns nothing beyond its statements validity. It's interesting properties, and this, if you realize these properties, you can interesting method who can hide your personal information. And today I can demonstrate this mechanism and how work this method. First, this protocol has two types. First, it's interactive and non-interactive protocol. Interactive, it's a situation when, in this case, two person, or maybe two sides. It's first, it's verifier and prover. And this situation when this process have maybe a third party is maybe a grant who generate initial data or and this data call it in toxic waste, and it's a situation when third party generate these same private parameters, and toxic waste has been destroyed for while scheme to be secure. And non-interactive situation when you generate public set parameters themselves, and other person who can check this parameter uses this public parameter of your public parameter and can approve or unapprove your knowledge. And it's two situation. And other situation, it's more by other situation. And to this moment, you have important question. If you have this trust setup, when you and this trust setup generate your private parameters, you must answer same question: who responsible for generation initial data or toxic waste? With the toxic waste has been deleted, and in this moment you need to understand risk. And to maybe answer this question, it's you you have few solutions. First, you can choose other realization which has no trust setup. Next, you have third party who are responsible for this process, generation toxic waste, and other solution, you might accept this risk because yes, so you understand it's okay. Okay, and let's look at an example to understand this essence of this mechanism, maybe protocol. Maybe it's first example. It's its protocol, and this protocol call it is science non-interactive arguments of knowledge, or maybe short name Zcash-NARC. And maybe first realization of this protocol, it's a realization of Zcash. It's situation when private transaction in Zcash and rely on public parameters for constructing and verify zero knowledge of proof. Unit generation public parameters, it's equivalent to public and private key pair, and you need to keep public pair and destroy it your public and your private key. Why? Because in case when attacker can copy this private key, this person can create counterfeit Zcash, and maybe this person could steal personal information as a participant, and this person could violate any else privacy of this system. It's risk, and you need to understand this risk because you can make your solution when you need variants of zero knowledge of proof protocols. Okay, and next on maybe let's make a little summary. This protocol, Zcash-NARC, this protocol has a trust setup, and this protocol has one proof for one knowledge. Okay, and next type of zero knowledge proof, it's science non-interactive universal arguments of knowledge. Its short name is SNORC, and SNORC with this universal and updatable trust setup. Yes, this protocol has trust setup, but this you can change your parameters for each maybe smart contracts, and maybe each message. It's if you tell about a universal and updatable, it's this protocol. If you need to change part of all message, it's good because you don't need the computation again or for one construction. Okay, and next it's next type, it's science or scalable transparent arguments of knowledge, or short name is the STARK. And for example, let's prove to public that Jan, it's our Jan, is not the offered database. For example, we have database, and it's database offered database, and I needed to check this information or existed or not existed. And first I generated key pair. It's maybe it's now look, it's 4 key pair as in our picture. And first step, it's I need to generate key pair. Next, it's you need competition, and maybe specific competition for this. I needed to compute hash from this private key, and it's the first layer on this picture. Next, it's next situation in next layer, it's concatenation between two value. It's like one moment. It's like concatenation to value this and to this, and it's value next to layer. And next step, it's a competition again into this value when concatenation value this and this. When we finish this process, next it's stage when you need to create your signature for this value. Okay, you have message when you it's message which consisted and personal data OAN and you create message and one-time signature. It's your message consisted in different value. It's signature of to this message, personal data, and other it's concatenation information your previous competition. It's like it's this, and maybe you asked how person choose value when you needed construction value for your proof. When verifier created this proof, prover will send way how need verifier created proof for him. And when and maybe third stage, it's verification of signature. You have key, it's public key, and each person who has this public, and this person make recovery information. First, it's you need to check signature. When a person verification, you need to understand, okay, this proof understands that verifier signed this message. It's okay, you need to understand who make this digital signature. And next step, you need to understand it's this information correct or not. I can found that Jan and maybe personal information existed of this database, or maybe not existed. Okay, and let's make a little summary for this method. First, this protocol hasn't trust setup. Next, this protocol are scalable and transparent. And this universal method for maybe each application when you need know information existed of this block data or maybe not. Okay, and next it's it's protocol bulletproof, and maybe let's say math. If you tell zero knowledge proof and you need to understand mathematics and maybe special area mathematics, maybe digit Galois fields and other. And bulletproof, it's interesting method because this protocol used when you need to check short proof. It's very size proof of this protocol. It's short. Next, it's but maybe this protocol have disadvantage because velocity of process speed of verification process and maybe proof process is not fast. And today it's more than 30 implementations, and the algorithm is based on different methods. It's this realization I implemented in the lattice-based cryptography and hash-based cryptography and code-based cryptography and symmetric key quantum resistance in other mathematics, but in this article we have covered the most common ones. It's this SNARK, it's STARK, and bulletproof. And it's you look, it's variant, so maybe type of zero of knowledge of proof. But if you tell maybe realization, maybe variant realization, you can see this realization in SNARK is sonic, Merlin, Plonk, and supersonic, and if the K-Stark at a free Starks and fractal and bulletproof at a hello. This realization have differently between each other. It's maybe one realization faster, other application maybe faster of proof process and maybe verification process. And if you tell about proof of size, it's Stark have more a bigger size of bigger proof of size that other variance realization. Okay, and next it's when after my research of these protocols, I got this roadmap. If you can answer serious question, maybe a lot of question, and or you know characteristics your application and maybe your system that the protocol should have, and will you get categories and possible realization. Okay, let's take a look on this roadmap. And first, it's performance. You need to understand the same characteristics as proof time, verification time, proof size, and cost. It's a specific characteristic when you need to pay a request to API, maybe cryptography API, when you use cryptography service of cloud provider. It's maybe it's service, it's as a software, as in KSM, or it's maybe Azure and maybe Amazon, and other services, maybe HSM, when you use hardware solution, and this solution set up in cloud provider, and you respond for this, and cloud provider have not access for this device. Next, it's transparency. It's a situation when you need to understand who are responsible for generation your private parameter. It's maybe not private. It's maybe it's initial data parameters, as in the toxic vast, and to you, and maybe you and this parameter are generation by third party, and maybe it's you have in transparency, and maybe you you want to realize universal realization when you change it parameters for each block, and maybe each maybe it part of all blocks. Okay, and next it's security, and it's maybe post-quantum security and strength of cryptography assumptions. And you need to understand it's an important thing, because because you need to understand it's maybe cryptography if if quantum computer will be exist, and your level of cryptography level of cryptography algorithm, maybe cryptography modern modern cryptography, and it's have a risk, and you need to change cryptography, and it's important, because you need to understand after if a quantum computer it will be exist, and you need to change it your all cryptography protocols. Okay, and when you have this roadmap, you can choose your zero knowledge of proof protocols. And in this slide show characteristics of each category. It's SNARK, STARKs, and bulletproof, and you can estimate each other. And to maybe it's you need to understand complexity. It's complexity proof or prover and complexity verifier and how many and communication complexity, when you need to understand how many requests for each other needed if you want to realize these protocols. And you need to understand you need to estimate proof of sites, because if you make proof for each message, it's one value. If your value will increase, you need to understand how increase your improve size. And gas cost, it's important thing. And next it's trust setup, and required or not required. And next point is security, it's post-quantum secure. And quality assurance, you need to understand your realization is strong or not strong. Okay, and next I made compare realization and type ZKP, and this result you can see on these slides. And first, maybe it's first point, it's you need to understand it's you need a trust setup or not, and maybe it's not, and you need to understand that ZK Stark faster than ZK Snark, and ZK Stark faster than bulletproof. But if you tell proof of size, you need to understand that ZK Snark it's shorter than bulletproof, but in this moment, the Castark shorter that bulletproof. But if you tell about in size of proof, it's good maybe advantage bulletproof has advantage. Okay, and next. Next, now that you learned a little about the evidence, and you can choose your approach. But you should know that it's the KP, and the KP required experience and expertise for mathematics and or cryptography and other type of cryptography, and this protocol required correct usage and security and threat model and other security things. It's maybe security control, and you need to understand known bugs, and maybe you need to understand vulnerability, maybe specific vulnerability for this protocol and this method, because it's maybe it's mathematics, and you need to understand how realization this method. Okay, and next, it's it's all. I hope the audience didn't fall asleep, and I have a couple of questions. Jan?
Yep. So thank you, Dima, so much for conducting this training. Sorry, this presentation. We have actually a couple of questions. The first one is added by Daniel. Could you please provide us with some examples where we can implement zero knowledge proof?
First, okay, I understand question. Thanks. First, it's you need to send your money, and maybe you can send money to me, and it's good, but maybe Hannah, maybe Alexander, and this person can see this personal information of this transaction. But because each is this person must be safe, maybe must collected all information, maybe all transaction in our system. But in this moment, I have not I have not that this person can see my transaction, and to this moment when I hide information, maybe transaction information transaction, and I use this protocol, and when I initialization this protocol, I use this. I use it interesting method when I hide maybe number of number of money, and you didn't understand maybe I have this money or not, and this protocol not don't hidden your a lot of my money, but I can send your you my money, or you can send me to my money. You hide any information about transaction.
So in that case, can zero knowledge proof can be treated as an alternative to private keys?
Sorry, Jan, can you?
Yeah, sure, no problem. So if I understand correctly, because of like increasing computational power in today's world, like zero knowledge proof seems to be more safe and more secure than the private keys in general. So just wondering whether zero knowledge proof can be used as private keys for securing any kind of transaction.
Yes, 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 agree. First, it's public key infrastructure is good method, but this method cannot use in this moment because you hide you you understand who answered it, and this
Replied.
person, yeah. And you understand information because you see this information, but zero knowledge proof hiding any information of this process. Maybe you need to pay for pizza, and market asked you you have $1, and you don't answer it market, but you make proof for this. And market, you understand, okay, you have $1. But market don't know information how a lot of your money and your value.
Another question that we have is also a question added by Lubomir. Is there any correlation? Is there any relation of proof of types to Kademila design?
When you have when you choose when you need to choose realization and maybe zero knowledge and other protocols, and if you tell about blockchain and maybe distributed system, you have maybe block because you have an specific size of this block. It's maybe 1 megabyte and maybe 2 or maybe 4 megabytes. But if you need to create it, maybe choose zero knowledge proof, you need to understand which you have characteristics, because if you choose this protocol and when you need realization, you need to understand it's not correct solution. You need research and you need to find other variants because it's not correct. And maybe I answered his question.
Lubomir, you can write us in the chat, or you can post another question in the Q&A section to our speaker, and I'm sure that Dima will definitely answer at a later time. Now, if this zero knowledge proof is like a interactive method for one party to prove to another that the statement is true without revealing anything other than this this statement itself, a question to me is, does logical operators play any game in zero knowledge proof, meaning the ands or ors for the decision in the zero knowledge proofs?
I think it's maybe when you we tell interactive method and maybe interactive zero knowledge of proof. I used this protocol in maybe private blockchain way, because you understand each partitions of this system. It's maybe it's I am trust him. I trust them. It's it's accepted, but this method has a disadvantage. Yes, it's bigger proof of sites, and maybe you need additional computation, but it's you need trusted somebody, and maybe this person are responsible for that, because it's good method, but it's you have maybe one vulnerability. It's toxic vast. Why? Because if you have these parameters, you can create a fake transaction, and you in this moment you have not maybe private or maybe public key verifier. It's risk. You need to accept it or not accept it in this moment.
All right. Thank you so much for answering the questions from the audience, answering my questions as well. And also, thank you so much for letting me be a part of the presentation in your example with having Jan in the database. That's, a very nice privilege to me. So much appreciated. For now, I would like to thank you for conducting this presentation, and I would like to thank our audience for joining us today, for asking the questions to our speaker. I still encourage you to write any questions on the Community Z portal, and Dima will be able to answer your questions at the later time. Hopefully, Dima,
okay,
that's correct. And also, I would still like to invite you to all the remaining topics on today's day of our conference, and also on the upcoming days as well. For now, thank you so much for the attention. Thank you for the presentation, and I will see you again in just a few minutes.
Thank you. Have a nice day. Bye-bye.
Take care, everyone. Stay safe.